Today's video, we're going to be taking a look at the harmonic mean within Python. We're going to solve it manually, and then we're going to take a look at two libraries, which really simplifies this down to one line of code. Isn't that awesome? But before we do that, I want to go over a little bit of the background of the harmonic mean first. So let's take a look at that, and then we'll get to coding. All right, let's go over some quick info on the harmonic mean before we code this out. So first, it's really an average is calculated by dividing the number of values in a data set by the sum of the reciprocals of the values. Particularly useful when dealing with rates, ratios such as speed or density, or where the average value is not linear. This gives more weight to smaller values and is always less or equal to the arithmetic mean. Other thing to note is our harmonic mean cannot be calculated with the data set that contains zero values. For in this example over here, right? You can't divide 1 divided by 0. Just not possible. So let's take a look at how you can calculate this. And I love my running examples. So let's say we have two runners. They both run 5 miles. Pretty easy run overall. One runs at an 8 mile per hour pace, while the other one runs at 12 miles an hour, right? So what we're going to do is find the harmonic mean over those 10 miles between the two runners. So first we need to find the length, which if you go back to this formula is the n at the very top, right? That's the length. So there's two runners. So we now have n equals 2. Then you need to find the reciprocals. So we have 8 miles an hour and 12 miles an hour, right? They're both standardized running 5 miles. So what we're going to do is 1 divided by 8 and then 1 divided by 12. We go back to this formula, 1 over x1 plus 1 over x2, and it keeps going on, right? I made this easy with 2, so that's why we have 1 divided by 8 and then that. So now if we look at this equation, right? We have n equals 2. Then we have 1 over here, 1/8, and also 1/12. So you can see 1/8 plus 1/12. And I don't know why they formatted it. It's kind of weird. But anyways, the final answer is going to be 9.6. And hopefully this makes a little sense. We're going to go over two different examples of harmonic mean, but one of them will go through manual, and then the other one will be pretty simple. So the first one will also deal with runners. Second one will deal with percentages and returns. So let's start doing that. All right. So what we're going to do is we're going to import in statistics as st, and then from SciPy.stats import hmean. Okay. Then what we're going to do is we're going to create our data set. So let's assume that these are all runners and this is their miles per hour. So let's just grab a few of these. So I'm just gonna put essentially some random numbers in here that make sense. Don't want to put anything too crazy, but I think this is pretty good over here. And we'll say these are marathon runners because that's one of my favorite events. Well, ultras, but a little different. Regardless, the first thing we're gonna do, as we went through with the PowerPoint slide, we're gonna set our length. So set your length equal to n. So n equals the length, and then just put your runners in here. This automatically calculates the length. Although technically you could just count these and go 1, 2, 3, 4, 5, 6, 7 and say that. But regardless, I think it's easier just to do like that. Okay. Now what we're going to do is find the reciprocals and sum this up. And you can do this honestly in one line. So what we can do is reciprocal sum. So reciprocal sum. Hopefully I spelled that correctly. So we're going to sum these up. And the way that we can do this is we can say 1, we can divide it by x, and we're going to say for x in runners. Thank you, list comprehension. This makes it super easy, right? So x in runners, x is each of these, as I explained also in my, I think it was standard deviation video, where we talked about we can have each of these in lists, right, as x. This is runners. So what we're going to do is sum 1 divided by x for each of those across the board. So it'll be like 1/4 plus 1/3 plus 1/5 plus 1/7 plus 1/11 1/12, etc. And that'll get us our reciprocal sum. So let's do that. Awesome. And then honestly, it's pretty easy now. So harmonic mean is gonna, and we're gonna say manual equals, and all we have to take is our length, which was at the very top, right? Which is our n, and then divide it by this sum here at the bottom. So divide it by this sum. And what we'll do is grab our harmonic mean, And check this out, 5.328. So now hopefully we can confirm this. Let's take a look at statistics. So example 2, statistics. Okay, so let's take a look at our second example, which is going to use statistics. So we're going to say harmonic mean stats equals, and we're going to say st.harmonic mean, and then just pass in runners as your parameter. And then just print this out. So put this down over here and take a little bit longer than I thought, but 5.3828290. Look at that. One line of code rather than having to do all this. I mean, it's not too bad, right? 3 lines, but you can make it much more simplified with statistics. Let's take a look at SciPy. So example 3, SciPy. And what we're going to do, super easy. Let's go over here and we'll just call this SciPy. We're going to say that's going to be equal to our h mean, which we brought in with our import. Then put your runners in here. And look at that, 5.382822, and we have it correct. So I wanted to go over one more example because when I was doing research initially on harmonic means, a lot of references mentioned about like investments and percentages. So I want to share an example with you guys on that side of things. So we're going to go example 4 and look at investments. So investments, and what we're going to do is let's assume we have a list of investment returns. So investment returns, and these are all percentages, right? So let's say we have 4%, then we have 6%, 8%, then we'll go over 8%, 3%, 1%, and then 5%. So I'm good with those over there. Again, just put some single digits, be realistic. 8's not realistic, but sometimes it does happen, right? And then what we're going to have to do first is we're going to have to convert this to decimal. So convert percent to decimal. And the way that we can do that pretty easily is, let's go over here and investments decimal equals, and what we're going to do is R divided by 100 for R in investment returns. Look at that comprehension once again, making things really easy. Then what we're going to do next is find our harmonic mean. So all we have to do with that, use what you want, right? SciPy or stats. I'm just going to use SciPy. So I'm going to say it's harmonic mean 2, or well, let's put 2 at the very end. And then we'll put our investment decimals. All right. And then let's go back now and bring this to our percents, because if you looked at this right now, right, we have 0.03, but that's not in the same format, right? We add it in solid numbers. So to do that, we just multiply by 100. So harmonic mean invest returns equals, and then just multiply by 100 at the end. So times 100. And one more line of code to see this. And we're at 3.18. And you can see like the 1 really drags it down. We only have a 3, but 4, 6, 8, 8, 5. And this is why you want to take a look at your harmonic mean. So just kind of reiterate the points on like the Python side of things. So if you're doing this manually, what you want to do first is find the length of your list. Then you want to sum up 1 divided by each of the numbers in your list, right? 1 divided by 4, 1 divided by 3, 5, 7, etc. for these runners. Again, this is in miles per hour. That's the unit I'm taking a look at versus one at the very end. I was taking a look at percentage returns and I wanted to bring that to decimal. That's why it's a little bit different. But regardless, right? Then all we take is our length at the top divided by the reciprocal sum. That's what I have over here. You can literally do that in one line of code with statistics or SciPy. And lastly, if you're taking a look at investments, convert it to decimal first, right? And then what we're going to do after that is just throw it in here to h mean with SciPy. And then if you want to bring it back to that initial returns just times it by 100. And that is your harmonic mean. Hope you guys enjoyed this video on the harmonic mean. If you are new here, make sure to subscribe to the channel. One of my goals is to scale up the channel to about 25,000 by the end of this year, and hopefully hit 100,000 in 2025. Now, if you want to learn even more Python or statistics, I have a ton of videos here on the channel. I'll link a few down below in the description that I think you should check out, and I have a playlist right over here.